be going over using transformations of quadratic functions with word problems, and I just have two of them for you. Okay, the first one says the height h in feet of water spraying from a fire hose can be modeled by h of x equals negative 0.03 x squared plus x plus 25, where x is the horizontal distance in feet from the fire truck. The crew raises the ladder so the water hits the ground 10 feet farther from the fire truck. And you're going to write a function that models the new path of the water. So the first thing that we want to do is let's get our graphing calculator out and see where this original function, where the water actually lands when we put this function into the graphing calculator. Okay, so we're going to do y equals, and we're going to graph this, negative 0.03 x squared plus x plus 25. We're going to graph this. And now, if we graph this, we may need to change our window because it may be too small. And just by looking at this, yeah, we're going to have to go to our window. Okay, and I'm going to change this to 100. And then going by fives. And then negative 100. And you always can zoom out too if you want to. But I like to just change my window. And this is going by fives. And you can already see it changing in the window in the middle right here. So we're going to go back to our graph and we're going to see this. So this is our parabola. This is our graph graphed. Well, our 0, or our x, is where the actual water hose lands. So what we can do is we can do second trace 0, if you remember how to do this. And we're going to do our left bound from the positive, because we only can have a positive distance from the fire truck where the water lands. So we're going to get as close as we can to that 0. So it's left bound, and then we're going to move it to right bound. And then we're going to push enter. Okay, and if you notice, our 0 is at 50. Okay, so that means when this fire hose lands on the ground, where the ladder usually is, regularly is, it lands 50 feet away from the fire truck. Okay, but our problem says that the water hits the ground 10 feet farther. So 10 feet farther is going to be at 60 feet. So we need to rewrite an equation that allows this ladder to raise up enough so it'll land 60 feet in the ground. And the ground is 0, right? So we need to make this equal to 0. So what we can do is put 60 into the original function. So we do a negative 0.03 60 squared plus 60 plus 25. And when we calculate this, we get 0 equals a negative 23. Well, we want this equal to 0. So what do we have to do to 23 to make it 0? Well, we have to add 23 to make it 0, to make our function correctly land at 60 feet. So what we're going to do to our original function is we are going to rewrite it as the g of x equals a negative 0.03 x squared plus x plus 25. But to make this correctly land, we have to add another 23 on there to make it the correct function. So we now have the g of x equals a negative 0.03 x squared plus x plus 48. And that is our new function. And what you can always do is you can go back and you can plug in 60 for the x's and see if it equals 0 to see if you've got the correct answer. Or you can plug it into your calculator and graph it and see if the x actually lands at the 60, and that means at 0 feet it will land 60 feet away from the fire truck. Okay, let's do another one. This one's a little different. It says the height h in feet of a water balloon can be modeled by h of x equals negative 3x squared plus 24x plus 11, where x is a horizontal distance in feet from the launch pad. The launch pad is adjusted so that the water balloon lands exactly 9 feet away from the launch pad. write a function that models the new path of a water balloon. Now this one's a little different because it gives you the exact feet away from the launch pad that we wanted. So we don't have to use a graphing calculator for this one. All we have to do is plug in the 9 to the original equation. So this one's a little bit quicker. So let's say so we have to make this equal to 0 when it's 9 feet, when it lands exactly 9 feet away. So this is going to be a negative 3, 9 squared plus 24 times 9 plus 11. So when we get for that one is we get a negative 16. So what we have to do to make that equal 0 is we have to add 16. So we can say the g of x is equal to a negative 3x squared plus 24x plus 11. And to make this correctly land where it needs to be, we add it by 16. So our new function is going to be the g of x equals a negative 3x squared plus 24x plus 27, and that will correctly land. And we can always graph it to see if it's landing 9 feet away, or we can plug 9 in and see if it equals 0. We always like to check our answer.